In this video, we will learn how to find the derivatives of some transcendental functions. I have 7 examples here for you. Let's start with the first one. So we have e raised to x squared plus 5x minus 4. And as you can see here on the upper right of your screen, I already included the equivalent derivatives that we will use. So if we have an e raised to u, that's the same or that's equal to e raised to u times the derivative of u. So here, our u is this one. Okay, that's our u. So using the derivative formula, that's equivalent to eu times du, or the derivative of u. So eu, we will just rewrite that x squared plus 5x minus 4. So that's e raised to u times the derivative of u. Our u is x squared plus 5x minus 4. What is the derivative of that? 2x plus 5, right? So, mhm. All right, so that's the answer. All right. Okay, let's go to the next one. Okay, so here we have two terms, 4x squared and then negative 5e raised to 2x minus 1. So we just simply need to find the derivative of each term. So for the first term, that will just be equal to 8x, right? And then for the second term, again, we will apply the rule. So negative 5e raised to 2x minus 1 times the derivative of 2x minus 1, which is 2. And we can multiply that 2 and negative 5. So that will give us 8x minus 10 e raised to 2x minus 1. Right? It's not really as hard as we think, right? Okay, let's go to the next one. Now for this one, we need to apply the product rule. And here we have an e raised to x, and the derivative of that is just e raised to x, as you can see on the upper right side of your screen. Okay, so I'll separate this into two different functions to identify your f and g. So f prime g plus f g prime. Okay, f prime, that means the derivative of negative 3x to the fifth power, that's negative 15x to the fourth power, times g, which is e raised to x, plus negative 3x to the fifth power, and the derivative of e raised to x is just e raised to x. So now this is equivalent to negative 15x to the fourth power e raised to x plus or minus 3x to the fifth power e raised to x. So that's an answer, or that's our answer rather. We can actually factor that out. So I'll just put the word or, e raised to x times negative 15x to the fourth power minus 3x to the fifth power. So either of these two is correct. Okay, let's go to the next one. Okay, so here obviously we need to apply the quotient rule. I'll put the negative in the numerator. So negative 3 over 2e 4x plus 1. This is our f, this is our g. So f prime g minus f g prime all over g squared. So f prime, derivative of negative 3 is 0 times 2e 4x plus 1 minus f is 3, or negative 3 rather, and then the derivative of that one. So the derivative of 2e 4x plus 1 is 2e 4x plus 1, right? times the derivative of 4x plus 1. That's our u. So that's 4 divided by 2 e 4x plus 1 raised to 2. Okay, so this is equal to 0 now. Okay, so negative 3 is positive 3 times 2 is, so this is positive 3 times 2 times 4. Okay, so just multiply those numbers. That will give us 24 e raised to 4x plus 1 all over. I'll distribute the 2 to 2 and then e raised to 4x plus 1. So this will be 4, 2 squares 4, and then times e raised to 4x plus 1 squared. We can simplify this. 24 over 4 is equal to 12 over, and then here this is using the laws of exponent. If you look at this, that's e raised to 4x plus 1 raised to 1, right? So that means we have this twice. We can cancel one of the e raised to 4x plus 1, and that's the one on top. We will cross that out, and that will leave us hold on, 12 over 2. This is just 6. Yeah, 12 over 2. Okay, that'll just be equal to 6. So this is 6 e raised to 4x plus 1. Right? Again, I will just repeat that. 24 over 4 is 6, and then we have e raised to 4x plus 1 raised to 1, and then in the denominator we have a raised to 2. Using the laws of exponent, we will only be having 1 e raised to 4x plus 1. Okay? Let's answer the next one, and here we have an exponential term which is 3 raised to x, and we can find the derivative of that using this formula. Right, derivative of negative 5x is just negative 5 plus, so as you can see, that's a raised to x, which is 3 raised to x, ln of a, our a here is 3. There you go. So that will be the answer. Easy, right? Let's go to the next one, and I believe this is the second to the last, so this is the last one. No, I have 3 more. Okay, let's answer this using the product rule. I'll separate these two first. So 5x squared times 4 raised to x. So I'll write the formula again. F g prime. So f prime, that's 10x. Alright, g is 4 raised to x plus f, which is 5x squared, and then g prime is 4x ln of 4. So this will be 10x 4 raised to x plus 5x squared, and then 4 raised to x ln of 4. Okay, right, so that will be our answer here. Let's go to the second to the last example, and this is going to be the last. All right. Okay, so obviously here we will use the quotient rule. This is our f, this is our g. So for the quotient rule, we have f prime g minus f g prime all over g squared. F prime, that's x raised to 3. Derivative of that is 3x squared. Our g is just 4 raised to x. Minus x to the third power times the derivative of 4 raised to x is 4 raised to x times ln of a ln of 4. Okay. All over 4 raised to x squared. Now keep in mind that 4x, or 4 raised to x rather, times ln of 4, that's just also multiplication. So yes, I will write this for you. I want you to see this. Okay. As you can see here, we have a common factor, 4 raised to x. So we can actually take that out. That's a common factor, so 4 raised to x. And so what's left here is 3x squared minus x to the third power ln of 4. And the reason we did that is because in the denominator we have 2 4 raised to x. So we can cancel that and cancel the 2. That's going to give us only the denominator 4 raised to x. So now our final answer is 3x squared minus x to the third ln of 4 all over 4 raised to x. Right. Let's go to the last example. Again, here we will use the product rule. We have an f and a g. I'll write the formula here on top. So f prime g minus f g prime all over g squared. Okay. So f prime, that's 2 raised to x, which means that is excuse me, 2 raised to x ln of 2, okay, times 2 raised to x plus 5 minus 2 raised to x times the derivative of 2 raised to x plus 5. The derivative of 5 is 0, so the derivative of 2 raised to x is 2 raised to x ln of 2 all over 2 raised to x plus 5 square. Okay, let's see what we can do here. Yeah, so here this 2 raised to x ln of 2 and 2 raised to x ln of 2, they are identical, right? They're the same. So that's the common factor of those two terms, of this first expression and the second expression. So we can take that away. 2 raised to x ln of 2 times what's left here is 2 raised to x plus 5 minus 2 raised to x all over 2 raised to x plus 5 square. Now we have a 2 raised to x and another negative 2 raised to x. We can cancel those two. And that's going to give us 2 raised to x ln of 2 times 5 all over 2 raised to x plus 5 square. And that's our final answer.